What did you say the new Raspberry Pi was? An RP2035?
Yeah, R235X. Yeah, is the new model.
Okay. So, that's a fun episode. We totally have to do this. It's so topical.
There's so much to go into.
This is what we're releasing next week, isn't it? For sure.
And the thing is like, even though I came in and did a little bit of RP2350 research ahead of time, I haven't actually used the 2040. You've used the 2040 a couple times now, right?
Yeah. We use it's a recording. Perfect. We use the RP2040 prolifically. It's fantastic. It's a great little processor. The support for it and just like consistency of driver accessibility and compatibility with everything is fantastic.
And you can use the Arduino tooling, all of that stuff. So there's a bunch of criticisms of the 2040 that people say that the 2350 address. For example, the 2350 doesn't have flash memory built in, but that last 0 basically refers to something about the flash memory. And there's, I think there's a 2350X or A and B, which should have flash memory built in. And so you no longer need to route that. And you've done this flash memory routing a couple times, I assume.
The routing's trivial. I mean, it's an SPI bus.
It's easy.
So it's really not that. It's not like your sodium RAM or something like that where you need to be like really careful about signal integrity.
Right. So, and just to correct myself, 2350A and 2350B are the ones with. I don't know what that last number is yet, but I will figure it out.
So the RP2350 has optional included RAM, is what you're saying.
That's right. So you no longer need to put it.
Included flash.
Included flash, yes.
Okay.
Yes. I haven't used the RP2040, so like I'm almost bouncing it off you. I ordered. So first of all, I don't think with the 2350 you can easily buy it right now.
No,
I think.
It appears to be something that, like, I don't think you can buy it at all right now. It seems that there's, like, an express interest for the future button, and that's about it.
Yeah, that sounds right. But I think the Pico 2, which was also announced that the Pico 2 is going to feature the 2350, I think that's going to be available later this month.
Oh, wow, okay.
So, if you wanted to start using the 2350, I think you would just get the Pico 2, go through the standard dev board cycle, stuff like that.
That makes sense.
I guess going a little bit further back, like with the 2040, what's your development workflow? Do you usually start with a Pico?
When you say when do I start with a Pico, you mean on any board I design? Where do I start on the board?
Yeah, sure. I mean, let's go through the cycle. I'm particularly curious about the 2040 and the 2350 because I haven't used these before, so I'm not exactly used to the development flows you might use for a Raspberry Pi microcontroller unit. Okay. You know what I mean? So anyway, go ahead.
So typically when I'm designing a board, I think about basically what do I want the edges of my board to be? What's my API? Same as the software.
Yeah.
So how does it work? And I work back in. But with the RP2040, the most common case I've had it is I've just slapped it on almost every board we make as an additional sort of known good debug microcontroller that I can get to do almost anything, right? Between the PIO, sort of GPIO control, I can emulate pretty much any protocol you want on the periphery of it. I know that I can easily control it. It works with Arduino, and I can just slap it as a module with, obviously you have to have the external flash.
Right.
And an external flash clock typically, some configuration, the boot switches, but you slap that as a module on, and all of a sudden, you can kind of mux it into your I2C lines with a couple of 0-ohm resistors, same with the SPI. And if you have a question about, is that sensor working properly? You've got a typically known good or a typically known simple, remove a whole bunch of the elements out of it to have a play.
What's that pattern called to have almost like a debug microcontroller? Is there a name for this?
I haven't heard of patterns in electronics design in the same sort of mental framework as in software design.
Yeah.
How people sort of talk about design patterns, but we call it a debug build.
I see, a debug build. And then a lot of people use JTAG for something similar, I think, right? Or maybe not. Maybe JTAG helps you with your main microcontroller or whatever. Is that about right?
Exactly. JTAG kind of lets you talk to most of the peripherals within your microcontroller, or most of the boundary of your microcontroller, and your CPU a little bit separately. Lets you debug them separately.
Okay. And then when you build this debug build, do you usually put like 2 USB ports? What does that look like?
Yeah, literally there are 2 USB ports. I've seen some interesting stuff. So with the USB-C and 3.0 standard, there's a couple of spare pins. And those are actually allowed to sort of be whatever you want. Now, you have to configure your USB drivers appropriately to do that. But there's 2 pins in USB, the CC pins, that if you pull them one way or the other, you're basically telling it how you want it to act. And if you pull... I think it's both of them down. I can't remember what the configuration precisely is, but it basically means that now some of the spare pins are in a bit of a free-for-all state, a sort of debug state, and you can do whatever you like with them. So I've even seen people run SWD or JTAG over a USB-C cable, kind of muxing it into the same connector.
Oh, interesting. Okay, kind of forbidden, techniques to. Yeah, I feel like people do that a lot with. RJ45, just throw anything over it.
Oh, yeah.
Just break all the rules. And
Absolutely.
then somebody plugs it into a router and you're like, oh, no,
don't do that.
Huh. Okay, so I'm imagining, too, with Autopile, this is probably extremely easy where you have kind of a debug module and you can kind of plop it in there. And then it's like, it really wasn't that much effort and you have a world of debuggability. And yeah, I mean, that's pretty cool. And you can... It's like the alternative to add a bunch of test points and then maybe have something that plugs in. Like what I see with when people can't do electronics as code, they will build hardware modules, right? And so they'll have these kind of complicated plugs that go to another thing.
Yeah, some typically pretty expensive external test hardware.
Yeah, but you could just put it on the board if you have room.
Stuck it on the board if you have room. Yeah. And they're getting pretty small. And see, the external flash obviously is really the bigger thing than the microcontroller. External flash crystal, the supporting whatever caps, configuration resistors, buttons. But with the RP2350, what was it, B? They're going to integrate flash.
Yep,
they're going to stack flash directly onto the chip, which is really cool because for the first time, you can just have a Raspberry Pi microcontroller kind of act standalone as you kind of would typically expect from a microcontroller. Few of them have no integrated flash. It's a weird design decision.
Yeah, that's true. That's true. I guess it's like something people want to customize a lot, but with even a little bit of integrated flash, you can just put more on, right? Or just use a different model of the chip that doesn't have it if you do end up needing more. It doesn't seem like that big of a deal. So one thing I really like about this is I was watching some people build 2040 designs. I haven't done a 2040 design yet.
Yep.
And one of the issues they ran into is the flash chip might just be out of stock and you kind of have to switch your flash chip, right? I was thinking, yeah, the more chips you need, the more that can be kind of a problem, right? If you, granted, maybe you could argue, it's easier to find flash memory chips. What if the RP2350 goes out of stock or something like that? But there's kind of safety in numbers around chips sometimes, right? If everybody's ordering the same one.
They're more fungible, the flash chips, right?
Right.
But at the same time, you need to have one of them. And the problem is today, electronics isn't really fungible. You design and then certify around a specific, really precise, almost binary artifact.
Yeah.
And you can't turn around and start switching out those components without impacting that design and certification sort of
That's
loop.
interesting. If you changed flash memory out, though, that wouldn't usually require recertification, right? Or maybe the full board is certified as is.
Exactly.
Is that true?
Exactly. It depends on the application, of course.
Yeah.
So if for example, you design something and it has safety critical software on it. Now, let's be clear. You should not be running safety critical software on an RP2040 or an RP2350, even with the upgrade. Lunacy, probably not the right thing.
Really? And why is that? Why wouldn't people run safety critical things on Raspberry Pis?
There's a litany of reasons. But one, they haven't proven that these cores operate under, let's say, adverse conditions.
Yeah.
In actual safety critical applications, for example, they'll put 2 CPUs in the same package with the diodes offset by 45 degrees.
Oh, wow.
And so if you end up with like a high energy particle running through the IC, it's only likely to affect one. Any radiation from a certain angle is only going to affect one in the same way because they're in different orientations.
And this sounds like space grade technology, but I mean, do cars kind of employ these things? Are these all over? Or?
Cars typically use, so the self-driving architectures I've seen, they'll typically use just a bit more redundancy basically. But I mean, Tesla, for example, they have two completely parallel self-driving full computers basically. I mean, it's the same board, but there's two completely parallel pipelines looking at the same camera feeds, doing the same things. And if they don't agree, they will basically, I think the failure mode is typically they'll kick you out of self-driving. Obviously, for the future, that's not good enough because you might be asleep in the back.
Right. Oh, man, the dream to sleep in the back of a self-driving car.
Yeah.
Yeah, this is a detour, but I took a Waymo here. And,
me too.
Oh, no way.
Yeah. Nice. How else do you get to work?
Oh, it's amazing. But do you sit in the front seat?
Oh, no, God, no.
Oh, you got to sit in the front seat.
Really?
Yeah, because you can adjust it.
Oh.
I recline it. I get so cozy. And it's funny because in an Uber, I'm like eager to get out.
Yes.
Like that's my impression. But in a Waymo, I'm kind of comfortable. I'm like, if this took 5 minutes longer, I'd be okay. If it took a longer route.
It does take 5 minutes longer, and it'll wait for 5 minutes at the end. So if you want to finish whatever email you were writing in the back, you can just sit there.
I've worked from a Waymo, actually.
Oh, of course.
I've taken on my laptop. It's really easy.
I typically do.
Yeah. But I wouldn't do that in an Uber. It would be too jostly.
That'd be so weird. No, too jostly for sure. And just like kind of weird. You got another person around, or if you're on a call, you don't want to, they're typically on a call, so you don't want to disturb them.
You don't want to mess up your Uber driver's call.
No, mate. Okay, so pitch for the back seat. If you sit behind the passenger seat, you open the front door, you move the seat forward all the way, and you have legroom galore.
That's true. I get to my Waymo early. Yeah. That's the best way to nap. That's the best way to nap.
I do wish Waymo, if you're listening, please add a button on the screen to fold the passenger seat, and for that matter, of course, the driver's seat all the way forward, so anyone on the back bench, just on the touchscreen, they don't have to fuddle around with it, has perfect comfort from the get-go.
That's true. They have to have electric control of all of these seats.
They do.
Yeah. I mean, I hope they do because I really adjust that shotgun seat. So that, if somebody gets in the back, they would be uncomfortable.
That would be uncomfortable.
Okay. Back to the Raspberry Pi.
Back to the topic of the day. So in terms of dual CPU, this is a very different application of it, but I've never seen a processor, a microprocessor before that contains two different complete cores that, from what I can tell of what they've talked about it so far, you at programming time decide whether you want to run RISC-V or ARM.
Yep.
That's an incredible decision. It's really interesting.
Crazy. Yeah. It's really, really cool. After I saw that, this was the first time that I was like, oh, yeah, I mean, if it's easy to try out RISC-V. Because the thing about a lot of RISC-V things is the high-end chips are kind of like, I think they're like Chinese, and they're trying to get out of IP things, I think.
I think so.
So they're not like the first thing I would reach for in most cases.
They're risky.
They're risky. But with this being available in the ability to switch, I mean, this is a huge thing for RISC-V because now you can kind of play with it and see what happens.
It's massive, yeah.
Yeah, and then I think the appeal of RISC-V is it's a lot simpler. So if you are in the land of, I guess, like optimization, you might reach for that RISC-V because you're like, okay, I need this to run really, really fast on this, and ARM is really complicated. But even then, it's like, you would have to be building the compiler. So I guess what I'm getting at is I don't totally know why someone would reach for the RISC-V right now. Because when you buy that chip, they paid for the IP. So you're kind of paying the IP cost on ARM. But I do think it'll move RISC-V forward.
I think it'll definitely move RISC-V forward. It's an interesting point. Why would you take RISC-V today? From what I've seen of the performance comparisons of RISC-V versus ARM, the ARM still pantsers it every day.
Yeah.
Obviously, the toolchain support, the compiler support is way better. You've got RISC-V architectures for LLVM, for example, so you can compile basically the same source code to both at the moment, but the optimizations just really aren't there in the same way, and it makes sense. ARM's got decades ahead of it.
Yeah, the only thing I can think of is, if you are doing something in compiler or like performance is so critical and for some reason RISC-V is an easier target to if you want to literally be writing assembly. That's the only thing I can think of.
I think the RISC-V, to me, the reason I would consider reaching for it is if I were to be making custom silicon and I wanted to put a RISC-V processor in there because I didn't have to handle ARM. You know, like someone else is providing me a convenient open source instruction set, processor design. In this case, they're using Hazard 3 RISC-V cores.
Yeah.
Now, if you've got sort of multi-supplier of that really core CPU, then again, it's the same trade-off where you have something that's a little bit more fungible, but all of a sudden you might have companies that go under because ARM's, you know, enormous, historical.
Right.
So,
Absolutely.
You're pretty confident they're going to be around for the next few decades.
Maybe this is like a multi-stage play where they're like, Raspberry Pi is thinking, we want to be able to release, or at least have the optionality to release a RISC-V processor in the future, or without any ARM cores. I
think you're right.
Yeah. So this is really just step one. And then when all that hardware is released, people can be like, okay, well, there's a cheaper chip available now, the RP20 something in the future, 40. And we want to run RISC on it, on that cheaper chip. We can try it on our current chip. We can and sort of a RP2350 will be everywhere at that point. It does seem like it'll be everywhere. It seems like it's going to be an absolute hit.
I'm sure it's going to proliferate. Though, actually, that's really an interesting point because on the terms of alternate processor or instruction sets, the other one that is actually become major now because of the ESP32 is the TenSilica CPUs and instruction sets. So Expressive, again, being a Chinese supplier, didn't want to deal with ARM in the same ways. They wanted to reduce the cost. And so they've used TenSilica instruction sets on at least most of their processors from what I've seen.
Oh, interesting. I've never heard of TenSilica.
Yeah, they're in Silicon Valley. They're another American company, but for some reason their instruction set was licensable.
Oh my gosh, that's so interesting. Wow. Huh.
It's all happening. So it really is a demonstration that a sufficiently prolific microprocessor, one of these really open companies that just releases a great low-cost microprocessor, can really actually drive an instruction set change.
Yeah.
Should they invest in the tooling and the compiler tool chain for it?
Yeah,
so
absolutely.
If that all exists, I mean, hell yeah, I'm going to give RISC-V a crack. Like, let's see what happens.
Yeah, let's see what happens. Why not? Have you ever run like anything other than ARM on your anything other than an ARM core?
I've worked with PowerPC a little bit.
Okay.
But it's super transparent, honestly. Like at the level of firmware that I've written, I've never actually dealt with anything where the instruction set has actually mattered.
Yeah, same. I had to build for a MIPS processor, which is kind of weird, but they were probably doing the same thing as RISC-V, and it was really cheap. It's like a $7 Wi-Fi chip. It's like a HLK something, High-Link, and it was really easy. I basically just had to check that, we were writing like a Rust program. We just had to make sure that we were able to build for MIPS, and then everything was basically the same. I didn't notice.
Did it work? Yeah, I mean, it seams to be running. Are you sure this is the right chip? Yeah, I mean, it seems to be working.
yeah. It's like
what's etched on the top of it?
All right, so 2350. What else do we have here that's interesting? Oh, something I wanted to talk about was the PIO. Have you used the PIO before?
I have.
Why is everybody so excited about PIO?
Yeah. So the PIO, they're practically like if you're talking about reduced instruction set processors, which is what RISC is, of course. Now the PIO is that to the extreme end. It has, I think, 6 or 8 instructions that you're able to run. So very, very few. But there's a lot of them. It's basically having 6 extra cores in the RP2040 at least, right at the edge of your chip. So you can emulate, you can bit bang just about any peripheral you want and occupy a really stripped down CPU, but or at least just a processor. I don't know if you'd call it a CPU. It's not central anymore. But you can bit bang just about any protocol you want on those GPIO pins because you have a processor right there and in the edge. And it is able to shuffle data in or out, basically DMA style, to the main processor without occupying it all. And so if you want a CAN driver, or if you want additional USB-C ports, or if you want to do the USB power distribution negotiation, you can write all of that type of functionality.
Wow, it can do USB. Is that right?
I mean, you can basically make it do whatever you want if you're willing to write enough for it.
Wow.
But it's going to be lower level USB than you typically have support for.
Yeah, you're not going to get like the highest speed.
No, of course.
Okay.
No.
Wow, that's crazy.
Or if you want really strange PWM cycles, for example, so you can do like discontinuous PWMing. For example, you get more performance out of your FETs. You can kind of do all that type of stuff.
I think this is one reason why people liked the 2040 is because you don't have to put like a USB to UART chip on it, if I understand correctly.
You just have to put the flash chip instead.
Yeah, you do have to do the flat. Yeah, that's right. But I mean, now it's kind of, almost comes with everything. I do have a note here. The 2350, it kind of has more complicated power circuitry. People were talking about this.
Oh, interesting.
Yeah. So I pulled up, I can show you on my screen here. So this is the reference design for the 2350, and you have an inductor. You've got some complicated stuff, and it's very sensitive. They actually say in their document that they really recommend using their layout because they had to muck with this quite a bit.
Oh, enforced layouts.
Yeah. And I guess the RP2040 is not as complicated. I haven't read too deeply into why, but I don't think you have to place an inductor. Does that sound about right?
No, I haven't had to have any inductors. It's okay. So, I mean, if they give you the values and they give you the specific location everything has to be in, it's a slight inconvenience that they weren't able to make it a little bit more robust. But at the same time, as soon as your TS circuit or you're at a pile and you have this as a modular design, it's the same thing. Really.
Yeah, it doesn't really matter. Yeah, I think for us, we won't care at all. For us, it's like a do once. For the drag and drop tools, you have to be. I mean, some of them probably support some kind of modularization, but my understanding is nobody uses it. They just kind of repeat.
Yeah, you can also copy paste between them. So
you can copy paste. Okay.
I hope that someone does a good job once and at this level of configurability, because they're fixed value, small components.
Right.
The only thing is you're gonna have to go find those part numbers.
Yes. Okay. Here's a question with Figma. People. They have these massive Figma files with all these, like an entire design system in it, and they copy and paste between it.
Oh, really?
Is there an equivalent of that? Yeah, so you're doing like a new page on your website, so you pull up the design system Figma file, which is massive and barely loads, and then you just kind of copy and paste each thing that you need. And Figma has components and stuff like that, but it all kind of becomes one big Figma file at the end of the day, your design system. So do people do the same thing in electronic design, or are they like pulling up each reference project that they want or something like that when they're copy and pasting?
In my experience, the companies I've worked at, people are typically bringing up past designs and pulling chunks out of them.
Yeah,
now,
sounds right.
The companies that I've worked at are pretty scrappy, typically. And so I know there are better tools to do this. So you can have, the way they do it in Altium, for example, is a little fraction. They have sort of schematic block references,
right?
And they have layout ones separately. And I can't remember precisely what the block reference looks like back in Altium schematics because, as I said, people I've seen have just actually copy pasted the blocks and the references of those.
The thing is that if the software doesn't make the easy thing to do also the best practice, then you have a problem.
No.
Like with Autopilot TS Circuit, it's going to be very natural to create a function. You want to do it even on your first design, create those modules and that nice separation. But
I do agree. It's like the path most walked should be the easiest thing should be at least default best.
Right.
And if you want to push those boundaries, you're probably going to have a good reason to do so. It shouldn't just be for fun.
Yep. Maybe, I mean, kind of a new ecosystem coming together here. Maybe people who, use KiCad or Altium put up some stuff to make 2350 not a pain in the ass to put together, especially because there's so many cautionary warnings on this power circuitry here. That's just
at least they spell it out for you.
Yeah, they do spell it out. Yeah,
the data sheets from Raspberry Pi, at least in my experience, have actually been really fantastic. Great application.
Oh, incredible!
Really easy to put together.
Yeah, I love how it looks like they have a bunch of KiCad screenshots in their hardware design guide that kind of walks you through each part. We talked about earlier capturing design intent and stuff like that, and they really spell out why they did everything the way they did, which is awesome. So you have so much context, what you can and can't remove. I think they, in the 2040, they even were like, For the flash memory, their data sheet says you have to do this, but we found you didn't need to do it. So they've like run experiments, which is pretty cool. So yeah, great org. Never would have imagined Raspberry Pi would become this prolific in 2012 or whatever when the first ones came out.
No, it was like everyone was saying about that about Bitcoin at the exact same time. Hey.
Oh yeah! Wow! Oh my gosh!
You remember people trying to harvest Bitcoin back on Raspberry Pis back in the day? Very different game these days.
You know, some of those people, we laughed at them then, we laugh at them now. I bet they made a lot of money.
I bet they made so much more money than
because they were out there, they were trying stuff, you know, truly
experimenting.
Truly experimenting. They were in the arena, and so they probably got some money out of it.
I think the thing that at the end of the day separates them from, you know, like laugh at them, but like I think the thing that separates them, Raspberry Pi, enterprises like this, is they follow through. You know, you take it through to somewhere where you actually get that value, and it's really disproportionately awesome. And you have some fun with it as you go.
Absolutely,
it's a great way to be.
Yeah, and I think Raspberry Pi has had they've been mostly on point, but like stuff like the compute module, I don't think got the I don't think it did what they wanted to do. I don't hear. I really like the compute module still. I think it's a great idea. But same with like SparkFun Micromod. I don't hear about people using it too much in like kind of like. I guess we both talk to a lot of startups who are starting hardware companies. I don't hear it mentioned too much. I hear like other things being used or custom boards, almost always custom boards or simpler dev boards being used for initial prototypes.
Yeah. The compute module is an interesting sort of mid-step because I've seen a lot of companies and even products mid-manufactured, shall we say, in the thousands.
Right.
Like a laser cutter I saw, for example. And they just embedded a whole Raspberry Pi, sort of as is. And like
wait, the one with like the headers and all that?
Yeah, just a full Raspberry Pi. And all they were using to communicate with the rest of their board was the 20 pins. Because if all you want to do is talk to, so like typically the architecture in one of these systems, and actually this rolls perfectly into our next episode, but typically the architecture in one of these systems is that you've got a Linux computer, which you use to handle your UI, your external interfaces, convenient peripheral things like an RJ45 and USB-C ports, which the full Raspberry Pi includes, but the compute module does not. And so you would yourself need to stick those things on a board anyway. And then you talk to something real time, typically just like a general centralized microcontroller, and give it instructions to coordinate the robot. In this case, it was a laser cutter. And if you're just going to do that via SPI anyway, well, you've got a perfect 0.1 inch header with 20 pins and an SPI and an I2C and some GPIOs for convenience.
Right.
Why would you embed the compute module when you could have just actually had all of the connectors that you need mass manufactured, high quality, pre-laid out? You don't have to think about it. So you would maybe upgrade if you wanted to move those to a different location on the board or something. But it's actually kind of like a niche little corner in which you need to do that. I've seen it a lot more now with the Compute Module 4 because people are starting to use Raspberry Pis more prolifically as just like general purpose industrial computers.
Yeah.
Where they stick them in what's in place of where you might have previously had before some kind of PLC.
Right.
And so if you're doing that and you're making like basically a somewhat hardened enclosure and all that type of thing with different peripherals, okay, yeah, that totally makes sense.
Yeah.
But for the weird step of like products, particularly like consumer or like startup-y type products, it's kind of hard to justify.
Yeah. Well, I hope it takes off for. I mean, yeah, that's how it makes sense. Industrial designs, machines, whatever. You can drop in your compute module because you kind of do need a custom board. So like you kind of have to get away from the Raspberry Pi.
The one thing that I would love for them to break out over the 20-pin header is USB 2. Because the great pairing of this is that you want a RP2040 or now RP2350 right next to your Linux computer, connected to it at a reasonably high bandwidth.
Yep.
And the SPI is pretty good for that. But even more conveniently, you can use the firmware upload with all the existing tooling and whatnot that can just run on that Linux computer, and then it manages the machine. That's the match made in heaven.
That is pretty cool. Do you ever miss how I guess Yeah, I mean, I guess we're just getting away from this, but the early Arduino Uno, you could kind of like program your big dip component, and then just kind of take it out and plop it into something. That's kind of the compute module in a way. How many people were actually taking out the chip and putting it into something else? Like, because do you see what I'm saying?
Yeah, I see what you're saying.
It's like that extra step is just a little bit too much.
Do you remember back in those days how people were still using things like VeroBoard though? They're like line strip board and taking like
VeroBoard?
VeroBoard. Yeah, it's like the prototyping board.
Oh yeah, no, that's where I would see that dip component moved all the time.
Exactly.
Yeah.
So you take a Stanley knife to it and you cut your traces into it. Now this is back in I guess the 2010s kind of deal.
Yep.
Or like maybe 2008. I'm trying to think of the first time I would have tried to do that with an Arduino specifically. And it's kind of fine. But the difference I think that's really cool is you can do that once. And I came across a startup developing some wearable tech the other day that actually did that. And it's perfect. Their first like sensor signal ingestion and processing, power supplies or whatnot, knock it together like that. Yeah, fair enough. Makes sense. And you prove it out. But okay, like that's something that you do because you don't want to go through current tooling. You get the feedback loop down to a day. If you're really confident it's going to work, I actually want 10 of those things.
Yeah, exactly.
And I don't want to make 10.
Yeah. Again, occupies that really weird space. Those were bigger, I think, or made a lot more sense when it wasn't so easy.
It wasn't so easy. Yeah, JLC PCB. I'm sure they probably existed back then, but we didn't have access to them the same way that we do today.
Right. Yep. Okay, I feel like that's probably a good part one for our RP2350. I think we're gonna end up doing more on the Raspberry Pi, particularly when we get some units in hand and we actually play with it. Yeah. I think it'll happen.